In this lesson, we're going to be looking at creating or writing systems of linear equalities. So first of all, we're just going to remind ourselves that to check to see if an ordered pair would be part of a solution, all we have to do is plug in that ordered pair to the two equations to see if they are true. So if we were to graph these two lines that are right here, would the ordered pair 2, 1 be part of the shaded, double shaded region? We can do that by plugging it in. Our 2 is our x, our 1 is our y, so we're going to plug those in. So for the first equation, if we plug that in, we would plug in 1 for y. 1 is less than, and then we plug in the opposite of 2, which is negative 2, plus 4. Then when we solve that, we see that 1 is less than 2. Is that a true statement? Is the number 1 less than or equal to 2? And it is, so that's true. But they have to both be true. So now we're going to plug in the same numbers, but this time to the second equation. So we plug in 1 to y. Y is less than or equal to, forgot the equal to sign there, 2 plus 1. Is 1 less than or equal to 3? It is. So if we were to graph both of these lines and do our double shading area, that would be part of the shaded area. It would be one of the solutions. Again, we're just going to practice seeing if this ordered pair would be a true answer. Remember, the 2 is the x and the 0 is the y. So when we plug those into the first equation, we plug in 0 for y. So 0 is greater than or equal to 2 times 2, and 0 is not greater than or equal to 4. So 2, 0 would not be part of the solution. We don't really even need to go on, because if one of them is no, then it's not going to be a possible solution. So that's how you would check your answers when you finish. Now let's look at writing some inequalities and graphing them. In 1 week, Ed can mow at most 9 times and rake at most 7 times. He charges $20 for mowing and $10 for raking. He needs to earn more than $125 in 1 week. Show and describe all the possible combinations of mowing and raking that Ed can do to meet his goal. List 2 possible combinations. First of all, we need to look at what variables we have. In this scenario, we have mowing and we have raking. So what if we assign x to mowing and y to raking? One of them is not dependent on the other, so we can just write it this way. This inequality is actually, this scenario is actually going to have 3 inequalities, because when it says that he can mow at most 9 times, then if x is mowing, then we could say that x is less than, I'll go ahead and do this, or equal to 9. This represents the mowing. And for raking, it says that he can rake at most, but no more than 7 times. So that is y is less than or equal to 7. And then we have an equation for the total amount that he's earning. $20 for mowing would be 20x, and $10 for raking would be 10 times y, and he needs to earn more than, so this amount needs to be more than or equal to $125. So you can see here the 3 equations that we wrote, 1 for mowing, 1 for raking, and 1 for the total that he will earn. Now in graphing this, on the first one, x is less than or equal to 9. We go to the x-axis, find 9, and then we're actually going to draw a vertical line straight up. So there's x is less than or equal to 9. It's less than, so we would shade the area to the left. Y is less than or equal to 7, so we go to 7 on the y-axis. We're going to draw a horizontal line, and it's going to be less than that, so we shade what's below it. So far you can see that this area has been double shaded, so we know the solution is going to be in that area somewhere. We still need to graph the last line. Since this is in standard form, it's really easy to find the x and y-intercepts. So if we plug in 0 for x, then that term goes away, and we just have 10y is greater than 125. So y would be greater than 12.5. And for the x-intercept, if we plug in 0 for y, then that term would just go away. So that goes away. So we just have 20x is greater than 125. And we find out that the x-intercept is greater than 6 25/100. So if we go to 12.5 on the y-axis here, and we go to 6 1/4 on the x-axis, and we draw a line. There's all the PowerPoint that's going to pop up there. There's the line. This time it's dashed because it's not equal to. It also says it is greater than these. So for it to be greater, it has to be shaded above. So now you can see that the shaded region, let me use a different color here than the red on the PowerPoint. The triple shaded region would be right here. So what solutions he could do would have to be one of the ordered pairs within that shaded region. For example, let's say we picked the ordered pair right here. I'm trying to see my PowerPoint. Right there, then that looks like it would be about 7 for the mowing and 5 for the raking. And you could find 2 order pairs and pick those. Here's another scenario. Sue is buying t-shirts and shorts. T-shirts cost $14 and shorts cost $21. She plans on spending no more than $147 and buys at least 5 items. So again, we have 2 variables. We have t-shirts and we have shorts. One of them is going to have to be our x variable. One of them is going to have to be our y variable. One of the equations that we could write is going to be based on the number of t-shirts. She said at least 5. So the number of t-shirts and the number of shorts has to be at least, but it could be greater than 5. At least 5, but it could be greater than 5. Now we need an equation based on the cost of each. T-shirts are $14, shorts are $21, so that would be our 14x plus 21y. And she spends no more than, so this amount has to be less than or equal to $147. So again, here's our 2 equations. To graph that, we can, since they're in standard form already, it's going to be really easy to graph by finding the x and y-intercept. So with the first equation, if we plug in 0 to x, then that would go away and x would just be greater than or equal to 5. And if we plug in 0 to y, we're going to find that x is also greater than or equal to 5. So the x and y-intercepts are both 5. And we see that it's going to be a solid line. And it's going to be less than that. Or greater than that, sorry. Greater than that would be above the line. So we're going to shade everything above it. Now to graph the other. Again, it's in standard form. So an easy way to graph it would be plugging in 0 to find the x and y-intercepts. So if we plug in 0 to y, this becomes 0 and it's gone. So we just have 14x is less than or equal to 147. And that happens to be 10.5. So we know x is less than or equal to 10.5. So on the x axis, we're going to go to 10.5 and put a point there. For the y-intercept, we can plug in 0 to x. And if we plug in 0 to x, this term goes away. And we just have 21y is less than or equal to 147. And 147 divided by 21 is 7. So we know that y is less than or equal to 7. So we go to 7 on the y-axis. There's where our line is going to be drawn. So here's our line. It was less than that, so I shade below it. So you will see that the solutions are somewhere within this double shaded region in here. Roughly shaded. That's pretty messy, but that gives you an idea. So you would pick one of the order pairs in there. So one of the solutions would be, this one would be 5 t-shirts and 2 shorts. Or we could do 3 t-shirts and 4 shorts. since X was represented by t-shirts, this is our t-shirts numbers down here, and Y was represented by shorts, so the numbers over here represents the number of shorts, and we can find two possible combinations for that. That is creating and solving inequalities.